Let's look at fractional indices. What that really means is a case where you raise a number to the power of a fraction. For example, you have 4 to the power of a half. You might have, say, 9 to the power of 3 halves, 3 over 2. Those are two examples. Now, let's look at the 4 to the half. First of all, when you have a number to a fraction, the numerator of the fraction tells you the power to which you must raise the number. You must raise 4 to the power of 1. The denominator tells you the root of the number that you must find. You must find the second root of 4 or the square root of 4. So, working that out, what you get is the square root, right, this. But the thing is, once it's square root, you don't bother to write the 2. For any other number, cube root, you write the 3, fourth root, you write the 4, and so on. But for square root, you leave out the 2. So let's go back and leave the 2 out. It is the square root of 4 to the power of 1. In this case, I could do this. I could raise 4 to the 1 and then find the square root of 4. Or I could find the square root of 4 and raise it to the power of 1. In fact, let's put these in brackets. The square root of 4 to the power of 1. Or I could say I want to find 4 to the power of 1 and then find the square root. It doesn't make a difference. Alright? Although with bigger numbers you will find that it's easier on you when you find the root at first instead of raising to the power at first. But in any case, you get the same answer. Now, 4 to the power of 1 is what? It's 4. So what we really are going to be finding is the square root of 4, which is 2. In this case, what you have is the square root of 4, which is 2. Now, let us look what happened if we work this out. The square root of 4 is 2. 2 raised to the power of 1 is what? It's just 2. Alright? So, this tells you the square root of 4, which is 2 raised to the power of 1, gives you 2. This one tells you the square root of 4 to the power of 1, but 4 to the power of 1 is 4, and the square root of 4 is 2. So you see, you get the same answer. Alright? Let's look at 9 to the power of 3 over 2. In other words, 9 to the power of 3 halves. Well, as you seen a while ago, the 3 is the power to which you must raise the number, and the 2, well, the 3 is the numerator, the top number. It shows you the power, and the denominator, the bottom number, is the root of the number that you must find. Now, let's look at this. It is, you can find the power first or the root first. Let's do it at first by finding the root of 9, square root of 9, and then raising that to the power of 3. You will find that it is also equal to, if you raise 9 to the power of 3 first, and then you find the square root of that. Now, let's deal with this one. The square root of 9 is what? It is 3. And we have 3 cubed. 3 is 9, 9 3 is 27, because 3 cubed is 3 by 3 by 3. So it's 27. That's the answer. Let's look at this one. 9 to the power of 3. Now we're over here. We have 9 to the power of 3, which is the same as 9 by 9 by 9, and then we're going to find the square root of that. 9 by 9 by 9 is what? 9 9 81. 81 by 9 is going to be, where's my calculator, just to make it quick. My calculator says 9 by 9 by 9 equals a big number, 727. 727. So this gives 727. 727, and we find the square root of 727. So the square root of 727 is 27. So what you have here is the same answer, 27. Alright, both gives you 27. But as you see over this side, we found the power first. We raised to the power first, and then we had to deal with some big massive numbers. It's a bit easier if we find the root at first, because we are dealing with smaller numbers, right? Even though you get the same answer, it's easier to work with finding the root first than raising to the power at first. So let's make our conclusion here. If we have x to the power of a divided by b, what we really are doing is saying we're finding the b root of x, and we can raise all of that to the power of a. Or we could put it another way and saying we having x raised to the power of a, and then finding the b root of all of that. Alright, so that's what we end up with. Let me erase some of this. This look a little tight here. Let me redo this part. Finding the b root of a. A is the power, b is the root. Let me write a little bigger too. Remember, you must clearly write the power as a superscript. It's smaller than the number that you're writing. Don't make it look somewhat like this, x to the a over b. Don't make it on the same line. It looks like a times x times a over b, or x and a over b must be x to the power of a over b. Alright, so you could find the b root of x, then raised to the power of a, or same thing if you find the x to the power of a, then the b root. Well, it's easier to work with when you find the root first and then raise to the power, because you're working with smaller numbers. Alright, so basically the numerator of the power tells you, or the numerator of the index tells you, that you must raise the number x to that power, and the denominator tells you that you must find that root of the number, that root of x. Alright, so remember, any questions, comment, complaints, confusions, puzzles, and so on and so forth, just let me know in the comment section, and I will see you in the next video.